In 5.1, what we just finished, we graphed higher order polynomials. Now I can graph polynomials that are 5th degree or 7th degree or 99th degree, but I can only find the x-intercepts if it's given to me in factored form or if it's something I know how to factor. Some 3rd degree polynomials can be solved by grouping, group the first two, group the last two. But unless it can be solved by factoring, unless it'll factor some way that I already know how to factor, I'm going to have trouble setting the whole thing equal to 0 and finding the solutions. That's what 5.5 is about. How do you find x-intercepts of polynomial functions that won't factor using any factoring method we've ever learned? So it's only one additional step above what we've done today. It turns out that synthetic division is a great tool for finding the x-intercepts of a function that won't factor. And we talked about synthetic division in R.7, but that was a long time ago. So let's review it real quickly. I'm just going to write this down, and then I'll switch back to where you can see. All right, just write down these two examples, and let's make sure we remember how to do synthetic division. Some of you missed it on the first test, so we need to review. When you're doing long division, just like long division of real numbers in basic math, the steps are divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down, so there's nothing else to divide, multiply, and subtract to bring down. But one important step in long division is remembering that every time you go to subtract, you're distributing a -1. Most folks are lazy and just say change the signs. But that is lazy because nothing in math is hocus pocus. In synthetic division, we only have to change the sign once, and that takes care of, in long division, every time you multiply, you have to change the signs. Here's the one time you change the signs. You take the opposite of that constant in the denominator and put it in a little box that looks like that. Make sure you're taking the opposite because that's taking care of that very important step of subtracting in long division. Then out beside that box, you put the coefficients of the numerator. Make sure that the numerator's in descending order and see if it's missing any terms. By that I mean I have a 3rd degree term, a 2nd degree term, a 1st degree term, and a constant. So this numerator's not missing anything. This one is. I'm missing an x squared. I'll deal with it when I get down there. But this one's not missing anything, so the coefficients are 1, 1, -8, and -17. And then skip one line on your paper, draw a long horizontal line. Yes, you have got to be kidding. Okay, I believe you. I believe you. It is 2x squared. I just have already had my quota of mistakes for the day. I wasn't allowed anymore. That is on the handout 2x squared, so that second coefficient should be 2. Draw a long horizontal line, bring that first number straight down under the line. The reason you can bring that first number straight down is if you're dividing the leading coefficient by the bottom coefficient, 1, you're going to get the same thing. If this was 2x cubed divided by 1x, the first coefficient would still be 2. So you always bring that first coefficient straight down and then start the process of multiply, add till you run out of stuff to multiply and add. You multiply what's in the box times what's on the bottom row. 3 times 1 is 3. You put that under your next coefficient and then add. Then multiply what's in the box times what's on the bottom row. 3 times 5 is 15. Put that under your next coefficient and then add. Negative 8 plus 15 is 7. Then multiply what's in the box times what's on the bottom row. 3 times 7 is 21. Put that under the next coefficient and add. Negative 17 plus 21 is 4. Now my answer is not 1574, but those are the coefficients of my answer. If I'm dividing an x into an x cubed, what power will I start out with? An x squared. This 1 is the coefficient of x squared. And after that, the terms are in descending order. So that 5 is the coefficient of x to the first. That 7, well, the next lowest exponent would be 0, or just that term has no x. It's my constant. Since I've run out of powers of x, what must this last number be? That's my remainder. X squared plus 5x plus 7 is called my quotient, and 4 is my remainder. Now, in basic math, if you say 15 divided by 6, 6 goes into 15 2 times with 3 left over, how do you check that? You multiply your quotient times your divisor, and then add the remainder. 2 times 6 is 12, then add the 3 and you get 15. Same thing should work in algebra. If I multiply the divisor, which was x minus 3, times the quotient I found, x squared plus 5x plus 7, it would take a few minutes to multiply that out, but I could do it. I know how. If I multiplied that out and then added 4, it would give me back the numerator I started with. I don't have time to prove it, but, you know, at the party tomorrow, you could multiply x minus 3 times x squared plus 5x plus 7, and then add back your 4, and you'd get what you started with. And you'd get an extra s'more. Oh, me either. I think melty marshmallows are gross. All right, example 2. Practice this one more time, because what I've done on the handout, when you print it, now that we've reviewed synthetic division, the rest of the problems we do, I've already done the synthetic division, just allow us to go more quickly in class. So we're reviewing it so that you know how to do it, but then the next many examples, I've already typed the synthetic division. All right, what goes in the box for example 2? Positive 1. And then out beside that box, the coefficients of the numerator and what's missing? X squared. What could I put in place of the x squared that really wouldn't change the value of the numerator? 0. You could put in a 0x squared, and if you forget to, you're not going to get the right answer. The coefficients are 3, 0, negative 4, and 2. Somebody's pacemaker going off? Everybody's too embarrassed to check. Okay, 3, 2, 1, 0. I've got all my terms. Y'all go ahead and do the synthetic division just for practice. Is that what you got on your bottom row? What does that mean my quotient is? I divide an x cubed by an x to the first, I'm going to start out with an x squared. So 3 is the coefficient of x squared. 3x squared plus 3x minus 1, and then the remainder is 1. Which means if I wanted to check this answer, I could write that numerator as the divisor. The divisor was x minus 1. Times the quotient. Plus the remainder. If I multiplied x minus 1 times 3x cubed plus 3x minus 1, and then added that remainder, I'd get back the original polynomial we started with. Yes, ma'am. I quit. I am not coming back. Okay, what just happened? 3x cubed plus 3x squared. I left out the remainder. That's 3x cubed plus 3x squared minus x. No. Oh, 3x squared. Did I say x squared and write cubed earlier? I bet I did. I think I've said it right. I think every mistake I've made today, I've said. Yeah. Wonder what kind of dyslexia that is. I think I'm having mini strokes. Yeah, 3x squared plus 3x minus 1 plus the remainder. See, I even have it written right here. It's good? Okay, let me tell you one more thing. You don't have to write anything else down. We have the first 2 examples on the notes done, and that's going to help us get through with the material Monday. But let me just what if for a second. What if I divided 2 numbers in basic math and I got 0 remainder? What would that tell me? 6 goes into 18 evenly. Or what do you call a number that goes into another number evenly? It's a factor. If you get 0 remainder, then your divisor is a factor of the numerator. Those of you slamming books are missing good stuff, right? So algebraically speaking, if we divided this polynomial by x minus 1 and we didn't get a remainder, that would mean x minus 1 is a factor, and all of a sudden we would have factored something that we could not have factored before. That's so exciting, it gives me chill bumps to be able to factor something I've never factored before. That's what 5.5 is about, factoring by synthetic division, things that we could not factor any other way. The next 2 examples say use synthetic division to find the quotient and the remainder when f of x is divided by g of x. We're given 2 functions, f of x and g of x. We want to divide the g of x into f of x and give the quotient and the remainder. Now remember, you look for any missing terms, and this is a 4th degree polynomial. I have my 4th degree, 3rd degree, 2nd degree, 1st degree term, but I'm missing a constant. You have to treat a constant just like any other missing term. So I put in a 0 for that constant, and that's why this first row of synthetic division has a 0 at the end. Make sure that if I give you the divisor x plus 3, you put a negative 3 in the box. Then when you do the synthetic division, this is the bottom row you get. The first 4 numbers are coefficients of the quotient, and of course the last number is the remainder. Now, is there anybody who just needs to see one more quick synthetic division, or are we okay on synthetic division? No request for an example. That's why I typed the next several examples so we could just move through it really quickly. This function can be written as the divisor, which was x plus 3, times what would the quotient be if we were dividing an x into an 2x to the 4th? What power would we start out with in the quotient? Yeah, you subtract the exponents because you're dividing. That 2 must be the coefficient of your third degree term. So 2x cubed minus 5x squared. You could put in plus 0x, but since you're just writing your answer here, 0x is 0, you don't have to write it down. That 3 is my constant, and then the remainder is negative 9. You could either write plus negative 9 or just minus 9, and that's how you would check your answer. And we talked about that in the first 2 examples, how you would check your answer. You multiply your divisor by the quotient. I made that parentheses too big, but multiply by the quotient and then add your remainder. In my math lab, I think these problems, there's just a box that you type the quotient into. That would be these 3 terms, and a box that you type the remainder into. That would be the negative 9. All right, so example 4, we're dividing a third degree polynomial by x minus 2. That's why I have positive 2 in the box. I wasn't missing any terms in the dividend, so I did the synthetic division. I want to write this answer as the divisor, which was x minus 2, times, what's the quotient? Negative 4x squared minus 6x minus 15, and then the remainder you could either write plus negative 40 or just minus 40. But make sure when you're typing your answer in my math lab, you do say the remainder is negative 40. Type the negative in as part of the remainder. All right. Now, remember, this is all leading up to something big, and y'all are just hanging with me for a little while. Look at the next note that I wrote for you. If you let x be 2, if, for example, I gave you this original function, f of x, and said find f of 2, what does that mean? How do you find f of 2? 2 in place of all the x's, and you just get a number for the answer. And I could absolutely do that here. I could say negative 4 times 2 cubed plus 2 times 2 squared minus 3 times 2 minus 10. I'd get a number for that. But look at this equivalent expression and see what you would get if you put a 2 into it. If these are equivalent, then I should get the same answer, but this one's much easier to evaluate. Because if I let x be 2, what is this first factor? 0, and 0 times a bunch of stuff. It doesn't matter what the bunch of stuff is. 0 times anything is just 0. And then minus 40 would give me negative 40. That's leading up to a big theorem, the remainder theorem. If a polynomial f of x is divided by x minus some constant, in this case the constant is 2. If f of x is divided by x minus a constant, the remainder is the same thing you would get if you just plug that constant into the original function. Now, I'm not giving you a harder way to do something easy. If you just gave me this function and said find f of 2, I wouldn't use synthetic division to find f of 2. I would just plug 2 into the function. But you're just supposed to be noticing something here. If you use synthetic division with 2 in the box, and then you find f of 2 using this instead of that, it always just turns out to be the remainder, because the divisor, if you let x be 2, is going to be 0. The next 2 examples say for the given polynomial, use the remainder theorem and synthetic division to find f of k. Well, if you gave me f of x and then said find f of 4, but you didn't say anything about synthetic division, I would just put 4 into the place of x, punch that on the calculator, get a number. However, if you tell me to use synthetic division, I'll put 4 in the box, I'll do the synthetic division, and then because of the remainder theorem, I know that f of 4 would just be what? The remainder, 127. That's what the remainder theorem is saying. And if you don't believe the remainder theorem, you put 4 into this original function and punch it on the calculator, you will get 127. So what about example 6? Find f of 2. Well, I did synthetic division with 2 in the box, and the remainder theorem tells me that f of 2 would be what? The remainder, negative 2. And again, if you wanted to double check it, punch 2 times 2 cubed minus 3 times 2 squared minus 5 times 2 plus 4. It will give you negative 2. Mr. Kevin, what's making you frown? Light bulb's just not on yet? Or so far so good? Okay, all right. It's all leading up to something big. Yes, Miss Abigail. I'm glad you asked that. I meant to say it. If I give you the divisor, g of x, then you take that opposite of the constant, and that's what goes in the box. However, if instead of the divisor, I'm giving you k is what goes in the box. If I give you a k value, that's what goes in the box. That 4 in the box actually means the divisor would be what? X minus 4. That's when I'm dividing by x minus 4 that I put a positive 4 in the box. That's what the k is. Not if it's the remainder theorem, but anytime it gives you a k value, it's giving you what goes in the box. X minus that. Yeah. All right. The factor theorem. I kind of alluded to this last Friday or Wednesday. I said if you divide a number, say 3, into some other number 12, and you get 0 for a remainder, what does that mean? A few different ways that you could say it. But what does that mean if you divide one number into another and get 0 for a remainder? It means the first number is a factor of the second. The first divides evenly into the second. You could word that either way, but that's what the factor theorem is saying. If you divide x minus k into some big polynomial f of x, and you get f of k equals 0, that means the remainder equals 0. If the remainder equals 0, then x minus k is a factor of f of x. So number 7 and 8 say use the factor theorem to determine whether the second polynomial is a factor of the first. Now, notice I wasn't given a value of k here. I'm given the divisor. I'm given x plus 1, and that's why I have a negative 1 in the box. If you ask me what is k, I would say negative 1. K is whatever's in the box. X minus negative 1 is the same as x plus 1. All right, so I've already done the synthetic division. Just answer this question for me. Is x plus 1 a factor of this trinomial? No, because why? The remainder is not 0. It didn't divide evenly. I had some left over. So you're only looking at the remainder to answer the question, is x plus 1 a factor of that? Well, not if there's a remainder other than 0. What about example 8? Is x plus 4 a factor of that big 4-term or 5-term polynomial? Yes, because why? The remainder is 0. That confirms one factor or one binomial is a factor of another polynomial if you do synthetic division and get 0 remainder. And what that is all leading up to is letting us factor things that we couldn't factor before. If you just had given me this problem 10 minutes ago and said factor the function into linear factors, I would have looked at that and said, well, it has 4 terms. The only way I know how to factor something with 4 terms is by grouping. But if I group the first 2 and group the last 2 and take the GCF out of each group, I don't have the same thing left inside parentheses. Factor by grouping is not going to work on this problem. But I was given 1, 0. I was given k equals 1, and that's why I have 1 in the box. What does that mean I'm actually dividing by if I have a positive 1 in the box? X minus 1. X minus 1 is the divisor. And because I got 0 for a remainder here, I know that x minus 1 is a factor of that polynomial. What is the quotient from this bottom row of synthetic division? Exactly. 2x squared minus x minus 6. Yes, sir. It could be that you don't have a constant in the quotient. You just have 2x squared minus x. For example, you could put a plus 0 for the constant, but there would be no need to. Just like there's no need to put plus 0 for a remainder. All right, so being given one of the zeros of this function allowed me to factor this thing I couldn't factor before into a linear times a quadratic function. The directions don't say factor into linear times quadratic, though. It says factor into all linear factors. Linear means what? How do I know what a linear factor is? First degree. This is my linear factor. This is my quadratic factor. But this happens to be something I know how to factor further. This is the hard kind of trinomial. I can say 2 times 6 is 12, factors of 12 that have a difference of 1 or 3 and 4. Split that middle term and then factor by grouping. So I'm down to the point where I can finish the factoring whatever method that I would have used in chapter R. My preferred method is trial and error because I can. So I just factored that real quickly. But if you don't like trial and error and you had to go through grouping, it would have just taken you about 2 more lines. You would have ended up with the same thing. And that, by the way, is a 3. What's the most important thing you do anytime you factor? Somebody say, check your answer. Please, please, please don't miss a problem on the test because you were too lazy to say 2x times x is 2x squared, negative 4x plus 3x is negative 1x, and positive 3 times negative 2 is negative 6. If you have a sign mistake, you'll find it. Have I done what the directions said to do? Am I through with this problem? Yeah, I have 3 linear factors. I had a 3rd degree polynomial. I was given its first 0, which allowed me to factor it into linear times quadratic, and then that quadratic would factor further using traditional methods. So I have factored something that I could not have factored before. All right, example 10, same thing. I have a third degree polynomial that I could not factor by grouping. If you gave me that in chapter R, I would have tried grouping and then I would have just said, I would have said prime. I would be wrong. It's not that it's prime, it's just that I didn't know how to factor it until today. I'm given the first zero, -5. If I have -5 in the box, what does that mean my linear factor is? You could write x minus -5, but minus negative is the same thing as positive. So just write x plus 5. And then what is my quadratic factor? Perfect. 6x squared minus 13x plus 2. So synthetic division has allowed me to factor this into a linear times a quadratic factor. And that quadratic factor, it might take me a minute, but I can factor it as the hard kind of trinomial. Again, by trial and error or grouping, whichever you've gotten good at. And you should have gotten good at one of them by now. Actually, I think that's going to be 6x and 1x. Yeah. There we go. That last factor is 1x minus 2 or just x minus 2.